All right, it is 1 o'clock here, so we'll go ahead and get started. Just wanted to thank everyone for joining our webinar today. It is a insurance fraud detection solutions webinar. Before we get started, I just wanted to go over a few housekeeping items. There will be time at the end of the webinar for Q&A, so if you have any questions during the webinar, feel free to drop them in the Q&A box at the bottom of your Zoom meeting, or you can message any of the panelists or host. We are recording today's session. I'll be sending out an email with a copy of the recording later this week. And if you have any issues or questions during the webinar, feel free to message me, the host, Expero Internal. I will be happy to assist you. And with that, we will go ahead and turn this over to our speakers today, Scott Heath and Graham Gansel.
Hello, everyone. My name is Scott, and my counterpart Graham and I will be your tour guides today. We've got a pretty exciting agenda laid out. Graham and I have been working on this kind of insurance slash fraud prevention as well as machine learning. So we hope to have a great webinar for you today. So as we start off, we have a couple of different elements that we're going to walk through, which is what exactly can the new technologies today and some of the machine learning and graph and these really great capabilities, what can those really solve? But more importantly, then we want to talk a little bit about why and where these things fit before we get into the nuts and bolts. So that's really what we've got on tap for you today as we lay this out. Now, as we start to look at this, look, all the practitioners that we work with, and it doesn't matter whether you're in property and casualty, you're in auto, you're in liability, you're in disability, and whether you're in the front or the back office side of this, it's getting worse, right? The pandemic is driving a lot of these kinds of activities, and whether you're looking at Medicare fraud, or you're in an ER, or you're doing auto or property and casualty, right? It's just getting bigger and they're getting more sophisticated. And I think that's the core or the crux of where we're going here, is that the pandemic is absolutely driving parts of this. Is people are either sensing an opportunity to defraud us, and again, depending on which line of business of insurance you're in, the difference between upcharging, miscoding, claims, embellishment, if you will, or it's straight out fraud, right? It's all sort of piling on top of us. And I think that's the pure takeaway, is the deeper, the more sophisticated our opponents, if you will, get, the numbers get bigger. The other part to this is there's 2 or 3 layers to this. There's the actual fraud that as a payer or a provider, we may be losing. So we may be paying the wrong claims and losing money, but there's a dual edge, which is if we basically have false positives and we stop a claim for someone who should get paid, well, our promoter score and or their network now in today's society may indicate that they churn and they go to another insurance company. So there's 2 sides to what fraud can mean in this sort of insurance world. The numbers, again, start to flow down. So there's this idea that there is life insurance and other kinds of items that they're trying to spoof. There are auto accidents and other kinds of elements. But as you bring that down, that unseen cost, they're now becoming much more organized, and they've realized that if they get the claim, they're much more likely, given this number at the bottom, roughly 1.7%, is able to be prosecuted. So the ability to find, detect, stop a claim payment is much more beneficial. Now, by the same token, we don't want to falsely flag claims that should be paid and or what those elements are, because it can boomerang on us and it can make it even worse. So as we're trying to grow our top line, right now our bottom line intersect in this kind of world. And so what we start to see then is this deep link or complex, right? Most of the things that you're going to see today involve the data at a complexity level that starts to be problematic. The simple human can't keep up with all of it. Spreadsheets, SQL databases, they all do okay, but at a certain level, we need more horsepower. We need machine learning. We need the ability to do network analysis, graph databases, you'll hear those terms, et cetera. But the bottom line is I need to do more with the resources I have today. It's not that my resources aren't doing great and they're not catching fraud, but they need to do it at a higher scale, a higher accuracy, and effectively with either the same cost or a flatter spend on that. Now, listen to Gartner, they'll tell you that graph databases, machine learning, this ability to start to use analytics and centralize this AI or data. Now, again, they're not everything to everyone, but they have a concept here that's very important, which is this ability to start to have the system be smarter, find patterns, look for things that the human, it's very difficult for them to find, to be able to do that, and then make it simple. That's the one thing that's not on this graph, right, is that humans don't go away, right? They still have to be in the loop, and Graham will talk a little bit more about why the human still matters incredibly in this particular loop. Now, again, what are those graph items? Now, these are not spreadsheets. That's not the kind of graph that we're talking about here. It's the network or data connectivity. And there are ways to do or show graph in what Graham is going to talk about. So we can do things like communities. Are there connections of people that are connected to other people that are bad apples, if you will? There are ways to see those things. There's centricity or centrality, similarity, prediction, connectivity, and paths. Those are all very, very important elements that you can use machine learning for. We can use a graph database, or we can use the concept of connected data, which is really kind of what a graph database is trying to tell us. But one of the things that we want to do with this now is this new horsepower of machine learning, the ability to share with the human things that are good and bad, and now this ability to take the data, and in many cases, we have lots and lots of data, but how do I connect it so that it informs me in a much better way? Now, what does this mean for other kinds of data, right? There are other kinds of elements. So we have health records, we have auto collision records, we have P&C data, we have other kinds of data. Every one of these, whether you're in this other aspect, can now start to connect. So when we look at a claim for a house, is that similar to the auto claim? Is that similar to a dental claim? Maybe there are these connections of things if they have multiple products that are out there that are indicators that we can pull through to do those. And so what we're going to show today is a couple of different vignettes, whether it's in medical claims or personal disability or auto insurance, et cetera. They're all very similar, which is connecting the data allows us now to do that. And whether it's in health or in sort of pure claims, this connection of the data is where we really start to find the strength. And again, that's what we're going to focus our time on. So when we look at this, there are so many different categories over on the left. The first is just simply we have a disparate set of data. We may have 10 different sets of data records. We may have our policy data, we may have our underwriting data, we may have all of those informations, and we may want to connect those in a master data that makes sense. Is Scott Heath the same Scott Heath that's in the auto policy database? Is that the same as underwriting? Is that the same as his casualty or his dental or other kinds of elements, right? Then we see as we work down our list, then it could be everything from an inefficiency or inflation. It could be a chargeback, it could be policy, it could be pure fraud, it could be disputes, it could be risk. All of those are similar or adjacent use cases, all now need what we have on the right, which is what Graham is going to talk about, which is how do we find that connectivity? Where do we find those good and bad activities? And a lot of times we see in insurance that the customer 360 data is the same connected data. How do I sell different policies? How do I sell better policies? But then if I juxtapose that against negative outcomes, I now use the same style of those analytics to look for negative patterns, fraud, waste, misuse, right? Loss, miscoding, upcharging. They're all the same kinds of things, but the human in the middle is what the solution is. How do I see it? How do I understand what it is, put it in a way that doesn't give me all that technical mumbo jumbo, but at the same time, I can feel confident that that is really working to show the human, what do I need to do to find that? And that's where we're going to go today. So when we see this, today we're going to focus on the lower part of this, right? So how do I do everything from finding it, prosecuting it? Is it a risk? Is it a score? How do I prevent it? How do I connect it? And then let's try and look for claims that could be anomalous before I make a payout, right? Because as we saw, only 1% of those after I make a payout, I can really claw back legally. And it's very difficult to do that. So at its minimum, we can start to use this technology now to focus on these sort of very specific kinds of use cases. And again, this could be across any line of business. So again, whether you're part of a payer or provider or your PNC, et cetera, all of these still are in play. Now, why do we sort of try and talk about this? Well, we're learning today a lot about machine learning. And a lot of us think of the Terminator movie where Arnold Schwarzenegger is chasing us with AI and ML. That's not what we're talking about here. Graham's going to illustrate to us now. It's learning about patterns of data or connections that should or should not be there. We see there's a big boost in that. But now by using a graph or connected data with machine learning, we can start to see even more insights. And again, our final part of this is by adding a human, allowing us to visualize that, connect that data, we can see in excess of 17%. Now we have some anecdotes that we'll see here in a minute that are much higher. So these are just a few of our customers where we show what these things look like. Now we've seen upwards of 60 to 100% for different kinds of use cases. We've also seen other kinds of elements where we may look at the exact same data and find things that have not been found previously. So in these two cases, one of the ones we worked with was a large Blue Cross Blue Shield. We looked at some ER data, and they were unable to find what was potentially fraud in a data set for a year. We were able to find over $20 million in that same data set simply because we looked at it differently and we used some of the things we're going to talk about. Now, again, your mileage may vary, and we'll talk more about that here in a minute. So why is this so complicated? Well, the insurance, as most of the practitioners on the call will know, is this concept of multiple connected hierarchies or ontologies, as they're sometimes called, et cetera. But they are all separate networks. So for instance, we have claims and products and insurance elements that are out in the field. We're selling those to our customers, and they could be wide and varied. And there are lots of different connections that go underneath that include state and type. Whether it's a certain category, is it bundled? What are those products? What are the claims? What is underwriting? What are the prices of those kinds of things? Then we have to go look at a separate one, which is our member. What is their historical background? What are their membership? What kinds of things make them risky to go do that, right? There's a whole series of data, and it gets now even more complicated for that kind of data. Then we have to go into our back office, right? What is a loss? And is it truly a loss? Is it really connected to a cascade of other kinds of claims or payments? Or what are the minimum kinds of payouts? And what did the policy say? And we need that data to go back and connect to the first one that we talked about. Now, these are only three. There are multiple inside of these, inside of an insurance company. But this is why it becomes so data. What if we were able to take all of these and connect them in a three-dimensional concept? Now what I could do is, instead of running a 40 table or 50 table outer join in a SQL database or building a monstrous data lake, what if I could do that in a couple of different ways, both smartly in real time, accelerate with that sort of concept of connecting the data, and then running machine learning? That's where we're going here, is this capability can be extremely powerful in how we start to do that. Well, why is this becoming different? Well, what happens now is that our older methods don't stand up anymore, right? No longer is the smurfing or the analogy of, oh, I'll just take 2 cents and nobody will know, and then finally I'm going to punch them with a $200,000 insurance claim. It doesn't work that way anymore, right? The bad guys have learned that the patterns and the way that they do this are far more connected and much more devious, because they're designed to look normal, but there are patterns that we'll start to see that make them stand out. And that's why this gets even harder now, is take all that rest of that data. Now, your process, for those of you that are doing different categories, so whether you're detecting it, you may be in the loss department, you may be in the claims department, or you may be in the special investigation unit. All of those do very similar styles, right? I want to find something, detect it, flag it, and then maybe I want to solve it. I want to then identify, can I prosecute it, or can I stop it altogether? And then I want to predict it, and then I want to learn from it. And that is really sort of the core process pattern for the humans that are involved in this. And that's really what we want to show today, is how does this fit in line? The other big thing that we'll start to see here is that regardless of where you are, whether you're in the AML group or you're in chargebacks or claims or audit or compliance, you need to have your own way of looking at the data. But there does need to be a connected method where all of this can look for far more nefarious things or promotion on certain activities. Maybe the business items that you're looking at are simple claims items that are a point in time. That's okay. Maybe they're far more nefarious and they need to be connected. So the systems and the data underneath need to be able to support simple cases and the more complex versions with security, team roles, larger types of investigation groups. Again, whether you're in one of those or you're actually at the corporate level and you want to look at all of those different elements in one place. Now, these are some of the ones that we'll just sort of zip through here, right? So why is this so hard now in what we're doing? And what we start to see now is this ability to keep our revenue flowing, right? We want people to still buy our products and services. We want them to buy a home policy, and then we want them to buy a life policy, and we want them to buy our auto policy. We don't want to affect the people that are doing good. But what we do need to figure out now is this sort of crush of claims that may be coming in and doing more with less. Now, the technology on the backside has changed a lot. And we know that our IT partners are constantly looking for new things that are out there. But as one of our insurance companies said, I need another new technology, Scott, like I need a hole in the head. The point of that is now, how do we use technology that you already have, but how can we augment or bolt on this in such a way that give you that advanced analytic to be able to do that? Now, we're constantly sort of being overwhelmed now with state and local kinds of governances and the transparency and how do we do this and how do we have data governance and chain of command. Those are constantly there. But now with all of that additional pressure for regulation, et cetera, it gets even worse. So that's why this technology and some of the things we'll share today can potentially give you a big leap, not an incremental gain. Now, as we step through to the next section, let's talk a little bit now that we understand why this is so hard. Hopefully everybody's shaking their head and saying, no, we get it, Scott. We do this every day. We understand. And that's part of what we want to do now is let's talk about ways to solve the problem. There are two parts to that, right? So we mentioned, as Graham's going to tell us towards the end, is what is the technology underneath. How do we get that done? How is that done? But at first, let's talk about ways to augment this, right? So what we start to see now is there is this stack, if you will. If you're in the IT department, you want to be able to see what Graham is going to show us that shows us how to do that. But how do we create alerts? How do we create rules? How do we allow that to be flexible to use this new technology and a lot of the systems we may already have? How do I allow investigators or even first line claims managers to be able to do things with Customer 360 to tell our customers, to let them know things are out of whack, or simply that things are going as planned? And if there is conversation or input to the lower parts, we can do that. And if you're an executive, how do I get a handle on this in one place, right? That's really what we want to bring together today, is that ability to say everyone touches this proverbial element or elephant in a different way. And that's what we're going to show here in a minute, is what those look like. So when we start to see this data connectivity, there are many ways of showing claims or policy or what those kinds of components are. And we'll see those in a live demo here. But these are a few of the things that we can provide. Now, some of that data may be sitting in a SQL data store. Some of that data may be sitting in a data lake or other kinds of things. It can now be joined. And if there are already dashboards or investigation elements that are there, those can be utilized. So tableaus and clicks and those kinds of things. Some of the functionality we're going to show today is deep link analysis that can actually sit inside of what you already have. And it's designed to be fast and far more intuitive in some of these connected data capabilities. Now, time is a very important element. So there is this concept of where, when, and what happens. So the ability potentially to connect or to show deep link analysis can now manifest in a very simple way. Maybe there's a time incongruity. Maybe a claim has a different style of connection or other kind of functionality that needs to go on. So there are ways now to show that to humans that allow that to be far more intuitive and start to show where these things are going wrong. Maybe there are clusters in different regions or clinics in certain areas or other kinds of elements that lead to location that can also now affect that. And as Graham talks about the machine learning and how those things fit together, those can be what we call features or attributes that lead to what looks like a very simplistic risk score in this kind of user interface. And those are very important, right? Because the human may not know all that cool technical stuff, but they do know that with a score of 95 out of 100, that is something that I need to look at immediately. Then how do we do deep link analysis? How do I find those patterns? What if I found something? What if I want to find more of it? What if I want to find it and then stop it? Now what we can see are tools or visuals that allow, again, perhaps someone who's not a frontline customer service rep, but somebody in our analytics department to go find those connections. And we'll see what those look like here in some demos here in a minute. Then I can look for patterns. I can start to look for flow charts, something called a Sankey chart, before perhaps this turns from bad to worse. So maybe I realized that I stopped some claims on different kinds of things, or in my old world, the accuracy was very poor. Now I can start to see where those trends happen. Maybe they didn't actually leave our product or some of the other things that we were doing because it wasn't perhaps one event. Perhaps there were more events. Perhaps it was, a disputed claim and there were other kinds of things. But now we can start to find those hidden patterns of where and why the fraud indicators can start to build. So with that, what we'll do then is we'll show a couple of vignettes. In our first one, what we want to do then is that scoring capability, right? How do I use a machine learning backend to start to build in on this? In this case, what I've done now is my system has built this. And again, this could be in a Tableau or Power BI to do those kinds of things. But what I may want to do now is I look at this particular person, Fran Farmington. Well, Fran's been with us for a while. Now his insurance sort of background here is that he's got different kinds of campaigns. Maybe he's purchased a couple of different products from us. He's been educated on what that is, and he's part of a cohort for what those different elements are. And so what we want to do now is I want to see some information on time. Now, one of those things is before I get Fran on the phone, I may see that he's got some claims, right? So maybe it's a disability claim, maybe he was involved in an auto accident, and maybe there are multiple claims that are going on. So maybe we are paying his disability, and then maybe there's another part of our business that may be looking at his auto claim. So he's got two parts to this. But a customer service rep in this case may want to look at what his history was and what those kinds of things are. But in this case, I see that perhaps one of his claims are on hold. I can learn a bit more about my friend Fran here, where perhaps he's got disability, as I mentioned before, and maybe he's got other products with us. He's part of a group that we enjoy. He's part of an emerging cohort, but we sense that something is off here. There are two disputes. It's happened in a rapid fashion, and perhaps there's more here than meets the eye. In this particular interface, now what I can do is I can actually start to see what those things are. But then if I wanted to, I could dig in specifically on that claim. Well, look what I found. I found that there are multiple other claims with Fran, that there's more to this, right? So there was a doctor that was involved and his disability was in a car crash. And it looks like there are addresses that are incongruent. Well, how did I find what those are and what that is? And that's where the power of the system. Now, this is designed for more of a customer service rep. So maybe in this view, if you will, I see that there's a problem. I may share some of this with Fran, or maybe I do not. The second part of this is maybe now I'm an analyst. So remember that stack of different individuals. Now, perhaps what I'm doing is I see that, well, there's a lot of connections with Fran that are problematic. Now what I can see is, well, there is an auto claim in addition to his disability claim. And now what I can see now is I can see that, well, where is Fran? Well, goodness, with the algorithms and the machine learning, I'm able to realize that Fran is actually very risky. He is connected to IP addresses, perhaps to known other flagged fraudsters that have been linked in our system. I also see that perhaps there are some other parties or counterparties in his auto claim that are also listed. Now, over in my disability, I may have only showed him as a good customer, but there's something more going on here. So now what I can do is I can dig in. What I now start to see as well, there are multiple claims that are going on. So perhaps he's also claiming the disability. He's claiming perhaps in this case, two different claims for the auto crash. And what we've done now is we've been able to take what looked like something simple, but we've been able to take it a bit deeper. We now see that perhaps there's more to this. So that's kind of our first vignette on how perhaps, property and casualty or automotive, right? The second kind of claim that we want to look at is something along the lines of Medicare, or let's say I'm a Blue Cross Blue Shield. And again, I have similar styles of claims and I have similar styles of activities. Perhaps in this case, I'm a fraud investigator, and you can see now that I'm looking for, again, a slightly different variation of claims, but in the database and the data level, it's very similar data. And what Graham's going to talk about is, again, that's why this can be used for so many different use cases. But in this case, I can actually come down now and I want to go look at different kinds of claims. I want to perhaps go look at this in sort of a variation number one, where I want to say, show me where these claims are incongruent. And I mentioned before that maybe there's a geography section. So maybe what I'd like to do is go analyze that facility. Maybe what I can see then is there's something, again, sort of more going on behind the scenes here. And so what I can do then is I can start to look at, in this case, why are these things popping up for this clinic? Maybe the claims for Medicare or ER claims, as I mentioned before, are out of this. And I can see now that there's some weighting. There's a mismatch of those claims. Maybe the ICD-10 code is off. Maybe the doctor tried to give somebody dual different kinds of things that he's coded improperly. So I wonder, is there more to this? Now what I can do, again, I can start to dig in a little deeper. What I can then start to see as well, there's again sort of this set of data that's connected. I can see a physician, I can see a claim, and maybe I can see a patient, or perhaps even a regional area. So what I'm doing now is I'm digging a little deeper. Again, the system is bringing that data to my attention as a human. In this case, again, my old friend Fran Farmington, I may find, well, there are these connections to a doctor, and maybe that doctor has multiple claims and Fran has claims. So now all of a sudden, this is cascaded into a much bigger style that's behind the scenes. And maybe that's what I need to do. Maybe I need to go look at that physician. Maybe I need to sort of dig in different ways to go do that. And that's ultimately what I'm going to do now is I'm going to go in here and I'm going to say, okay, how do I start to go look at that second version? So what I've done now is I've been able to click through and I can see now Joshua is my doctor. Well, he's also got other locations, but he appears now to be this center of the different claims. So maybe Joshua and Fran are working together. And now what I can do is I can dig in a little deeper and then I can save that pattern. What I'm seeing as a doctor is in collusion perhaps with the different team members, as we saw in our previous demo. And now what I can do is I can go train my model. And the point of this now is this is where we start to move towards what Graham is going to share with us, is how do we use those concepts and the other kinds of things to make this kind of visualization, and again, for the person to be able to do that. So with that, we'll move to Graham.
Thanks for teeing it up, Scott. That was a great intro. And as I talk through some of the behind the scenes applications and methods here, I'll try to point out where these things intersect with the demos that Scott just showed. Overall, what we'll be looking at here in my section is the way to migrate your business from this sort of yesteryear offline analysis, one-off analysts working behind the scenes manually to come up with intervention mechanisms, like, for instance, surfacing a medical fraud claim, moving into the modern world where we have autonomous systems that are making those recommendations to our analysts so that they're much less burdened by digging through every single claim that streams in the door. And now they have this sort of top filtered list to say, these are the most important ones for you to look at. And here is why. So that is the pathway from sort of the offline analysis world that everybody used to be in into the data products world where we have these autonomous systems helping us make decisions. What we'll do today is we will talk about the supercharging power of using machine learning and advanced analytics in the background of these systems like Scott showed. As you can see here, there's a whole list of reasons why you should use this stuff. Not the least of which, of course, is increased accuracy, right? As I mentioned on the last slide, there's also decreasing the number of false positives that analysts have to manually dig through. And at the end of the day, really what this does is it allows our businesses to operate more efficiently and serve our customers better. And that's really the goal, right? We save money by not wasting time on evaluating claims that are obviously should go through, and focus those monies instead on bad behavior and malevolent actions instead. So I want to talk about a few different types of analysis. We see some graph analysis on the left. We see some machine learning analysis on the right. And the overall system I'll be talking about today combines these things. So it's really the intersection of combining graph analytics with advanced analytics, machine learning practices that allows us to get this true behavioral look at what our claimants and our service providers and our claims, how they're all interacting, and to do that autonomously. If you have questions about these various algorithms, you can look them up online. And one good place to do that is our website. On our blog, we talk about all of these different things in great detail. If you are in the business, I recommend it because it's interesting to dig in. All right, let me give you an overview of what the system looks like. This is like a data flow, a logical flow of data through the system. And at the very left-hand side of this diagram, of course, we start with raw data coming in from a variety of sources. One of the reasons that we recommend graph-based systems is because we can unify those data from whatever source they come in from, where it sits. And so as you see, as we move across this diagram to the right, we're actually mapping data in from its existing location into this graph system, and then doing some deduplication, some intelligent deduplication, to get the stuff rectified in that graph format so that analytics, whether it be by algorithms or by human interpreters, can be done seamlessly and without the sort of clutter of mismatched data and missing artifacts and all sorts of ugliness that we see in disparate data silos, like when you're trying to join together SAP backend systems with whatever Postgres systems your analysts might be using, and all of that legacy stuff that I'm sure we all have experience with. On the very right-hand side of this diagram, we see exactly this slide, which is the analytics system itself. The way that this works is at the top of this diagram, which essentially is the left part of the diagram on the last slide, we ingest data from a variety of sources. That's sources from in-house, that's sources from out-of-house. Maybe it's public open source data sets. Maybe it's data that you're buying from data providers. And then maybe it's things like sanctions lists or something, as you see in the right-hand side, from known bad actors. We do ingest that information because it is hugely valuable to take all of that knowledge from someone like the US Treasury to understand where things have gone bad in the past, because that is obviously a leading indicator that something bad could happen inside your own insurance network. That information is fed here into the actual fraud scoring risk engine, where fraud is probably too specific of a term. I mean, really, we're talking about fraud, waste, and abuse, and all of its associated components, like, for instance, payment reduction evaluation and risk estimation. And the critical thing here in the middle of this slide is that we're using several different mechanisms to make this judgment, to render this judgment to our investigators. So we're using machine learning and graph analysis, as we just talked about, but we're also using systems you already have in place today, right? I'm sure everybody watching this, their company already has some type of business rules engine that is doing a decent job, right? Is surfacing claims that need to be surfaced. And we integrate those recommendations into this system, right? It is just another mechanism for us, another judgment rendering system that our overall analytics package here considers in its scoring of potential fraud, waste, abuse, and associated judgments rather. And then at the very bottom of the slide, what we see is maybe the most important part of this entire slide. As Scott mentioned and then showed on the demos, this analysis only has any business impact if we can take action on the insights. And the way that we do that, and I'll show you here in a little bit, is we surface a judgment or recommendation to an investigator or analyst through the front end you just saw in Scott's demos. And we say, hey, you probably want to take a look at this. But indeed, if we were wrong about this, if we surfaced a poor judgment or recommendation, then tell us. And we have mechanisms in the front end. We have actual components in the front end to show you why the decisions were made by the system. That way you can, as an analyst or investigator, you can understand, well, I trust this judgment and it makes sense why this judgment said, yeah, this was a fraudulent claim, or this payment should probably be $10,000 lower. When our investigators and adjudicators look at this information, they inject their human domain expert knowledge back into this system by saying, yeah, great job. That was a good recommendation, or no, that was a poor recommendation. Don't show me that again. So that the system can get smarter over time. And I'm going to talk here in the next couple slides about how this system actually works and ingests that information. This is a high level slide about how the actual judgments are rendered. Starting over on the right-hand side at number 1, we actually take a chunk out of the graph, where the graph is exactly what Scott showed you before. It includes information about claims, claimants, could be doctors, could be automobile information, it could be medical service provider information. All of those things can be injected in the graph and linked together, which again is something that's can be hard to do if you're doing, as Scott said, 50 table cross joins and stuff in SQL. We extract those in number 2 there at the top of the slide, and the extraction is done in using patterns from traditional graph analysis, so that we make sure we grab all of the contextual information that's related to the analysis, and then injected into a machine learning algorithm, which may be a graph-based algorithm, as I showed previously. But indeed, it could also be a traditional machine learning algorithm. So if you already have models in-house, you can just consume this information on the back end to up-level your current systems. And then the outputs from those analytics are surfaced in the front end. And those are the flags and the scores and the recommendations that Scott showed in the demo. Let's step forward 1 slide and look at a specific case. So here we're looking at an example of hiding in plain sight. So Scott, this is the example Scott showed in his demo, where we had one doctor that was related to multiple clinics, seemingly innocuously, until you take another step through and see that the claims from those multiple clinics were actually related to the same person. That doesn't really make sense, right? A medical claim isn't going to be distributed across multiple service providers that are also associated with the same doctor. And as we see on the left-hand side of this slide, an extraction of a graph where that graph is the claimant, where the center of that graph is the claimant, injected into all that blobby stuff in the middle, which is an actual TensorFlow neural network. So this stuff is real, it's running in the back end. And then output from that is a risk evaluation, a forecasted risk evaluation that says, hey, you're over a certain threshold of risk here. And we know that because we've seen the connections between those doctors, facility, service providers, and indeed that claimant in Farmington at the end of the day there. So another example of this is an unsupervised look at something similar. So on the next slide, what we're going to show is a very similar analysis, except that in this case, you don't actually have to seed this system with any pre-existing, let's say, labels, where a label is a known fraudulent action or a known wasteful action, like a miscoding or misidentification in a medical claim. The way that this works is the algorithm crawls through the data, again, graph structured in this case, and it groups out separate groups of whatever entity you're analyzing. In this cartoon example, we're analyzing organizations. So this would be like medical service providers in the medical insurance context, or it would be individual group policies in the automobile context. And through that analysis and surfacing in the UI, as Scott showed earlier, you're able to look as a human being with domain knowledge and say, hey, the people in this group, we know that these people are behaving weirdly, and we want to flag this whole group. And what happens there, and we'll show this in a minute, is that you've got a full group of claims, or again, in this case, service providers that are probably worthy of investigation. And when you combine that back with the other information from the previous slide, you then have a really crystal clear look at who those people are. So on the next slide, I just wanted to set this up with the cartoon. On this slide, what we see here is the actual graph. This is real data, right? So on the left-hand side, you just see this blob of nodes and edges in a graph. And after we do this clustering, what we see here are these communities, or neighborhoods, we call them, in the right graph. And as we browse through them as adjudicators or investigators, we then can color those communities with our knowledge of who those people are. And that it makes this sort of investigatory process, that workflow, much faster, because we don't have to investigate the whole bunch of mess on the left. We now can look at only one of these colored groups on the right-hand side, which is far fewer entities, and it's far less time wasted. And then I'll mention one more thing here on the next slide with respect to this unsupervised work, which is the comparison of entities across groups within a graph. So in the next slide, what we see is a simple example of that. Again, I realize these images don't mean much because they're actual IDs labeled as some real data, but the patterns that we're looking at here are left and right, two different groups, right? These are claims that are related to one group. On the left-hand side, they are a good or a normal behavior group. And on the right-hand side, they are a bad or malevolent behavior group. And you can see just structurally, just intuitively by the shape of those things, that they're very different, graph on the left versus graph on the right. And that is a key distinguishing factor, key differentiator in using graph in the underlying analysis. That sort of intuition as humans we have here about the shape, these shapes are very different. That is what you get to encode into your analysis by using graph. And again, shape here corresponds to behavioral context of an insurance claim. So like in the medical case, that's like multiple, as we mentioned before, multiple claims per multiple service provider, all related to one doctor and one claimant. Or it could be in the automobile case, a bunch of different claims that were surfaced by individual entities, and maybe they're related to one group policy. But again, they look very different in the normal and the fraudulent behavior cases. All right, let me look at some explanations of why these things were surfaced. A lot of math terminology on this slide, but what's important to note is that behind the scenes, we're using all sorts of wild analytics, things that come from game theory, things that come from calculus of variations. And the reason that's important is because we use those mathematical calculations to come up with recommendations or reasoning on the front end that says, hey, adjudicator, we surfaced a recommendation that this thing is really high risk because it came from a risky or known suspicious zip code. Or we know that because this community has been connected, and community here, I mean graph community in a like a neighborhood in a graph, has been connected in the past to fraudulent behavior. And so therefore you should probably take a little bit of a closer look at this thing. Okay, so let's walk forward from the math lingo here and talk about what this really means in terms of system operation. And then I'll wrap up by showing you another UI example, what this really looks like to an adjudicator. So we have a human being who is an investigator, an analyst, an adjudicator at one end, interacting with this thing through the front end you saw Scott show earlier. So that is indeed the only mechanism that is needed to keep this system actively learning, which we call co-learning. So system and user get better together by collaborating. And it does that every time there's an interaction, right? So every time the user says, yep, this is a high risk claim, that information is collected and is used in the next cycle of learning in that active feedback loop that we see with that human in the loop feedback. Okay, so let me show you a UI example here. It looks like this. We saw this screen on the left in one of Scott's demos earlier. And what you see in the pane there on the left is some reasoning behind why this system recommended a rejection of this claim, right? There's a high risk. Every time we see this provider pop up in this type of geographical setting, there is a high chance that this is risky behavior. And on the right-hand pane, what we see is an ability for that adjudicator to go ahead and say, do you accept this or do you reject this claim? And either way, why do you make that judgment? Now, you don't always have to do this. You can choose to ignore this, because as we go through these workflows, we all know how many of these can come in a day. You can choose to ignore them. And even if you interact with only one of every 1,000 of these things or whatever that comes in, that's still helping the model learn in real time. And that is how the system updates and displays it in the front end. Now I'll show you one more UI here quickly. And then another slide and we'll wrap up. This is the part of the demo that Scott showed earlier. I wanted to sync back to this just to close the loop to show you when we look at this contextual information in the UI, right? Remember, this is a disability report that has been surfaced on a particular date that looks suspicious to our system because of all these connections back to the same doctor. All right, so keep that in mind. And what you get here as a reviewer, right? This is an investigator, claims investigator, is the ability to say, indeed, as we saw in the last screen and this screen too, indeed, this is a malevolent claim. This is a fraudulent claim, or at least one that should be reviewed further by an adjudication team. And here are the reasons why. And that is the whole workflow that like closes the loop back to the system to maintain that active learning component and allow the system to get better and better over time in that co-learning experience. All right, let me wrap up with one more slide here to just summarize everything we've talked about. And what we have is 4 components: monitoring of the activity that goes on in your system using graph-based analytics. The ability, this says graph ML CI/CD, the ability to inject those new methods into a full autonomous system. The active learning components we talked about, where the system gets smarter over time using co-learning. And then interpretability, which is the explanations of those decisions that were surfaced. And go visit our website if you're interested in those, because we have detailed descriptions of all of that stuff there. So with that, I am going to wrap it up and turn it back over to Scott.
Well, thanks, Graham. I think the goal here today was, how does Expero help you, right? So some of the customers we've worked with have taken anywhere from 6 to 12 weeks to be in production. Bringing that capability of machine learning, the ability of whether you have a graph today or you may need a graph tomorrow, or maybe it's data connectivity with the products you already have. That's really sort of what that is. The other element here then is, how do I use that to increase my accuracy and decrease the false positives? Our whole goal now is to make this modular and make it happen for your business. And I think really the takeaway then is, you don't have to do it the old way. These new ways are so incredibly fast and so incredibly productive that we hope that's what you learned today, is learn some new ways to think about this, look at some of the technologies and different approaches, and that we can help at Expero. And with that, Laura, we'll throw it back to you for questions.
Yeah, thank you so much, both Scott and Graham. Just a reminder, if you have any questions, feel free to drop them in the Q&A box, and we'll start the Q&A. A couple did come throughout the webinar. Scott, there was one for you. Is this cloud or on-premise? I have Guidewire on site. How would this work together?
So Guidewire is typically an on-premise, and some of you out there may have, perhaps a private version in the cloud. Our system will work in either. So if you have a native cloud, if you're in Amazon or you're in whatever the cloud of your choice is, effectively, our solution is designed to be agnostic. We don't care whether you're in a cloud or on premise. From an API or connector capability, we use several different types. And so the good news is we meet our customers where your system is. And again, we're very flexible in how we do that.
Thank you. And then I guess another part of that was, how could I get started with this?
it's easy as a phone call we typically will take some sort of sample or obfuscated data set, and then we connect to the data. And then again, we can show results in weeks and days. That's part of what we do. But it all starts with a chat about sort of what is your use case? Are you trying to do auto, health, PNC, whatever your line of business is, and or, what is your type of fraud that you're trying to do? Maybe it's loss, or maybe it's prevention, or fraud categorization, or it's truly fraud. Those are the things that you need to get started.
Thanks, Scott. And then Graham, the one that came through for you was, is there any specificity to the kind of data I need or the size?
Yeah, so as you saw in the demo, we can actually ingest many, many sources of data. And some of those sources are external, right? So we will do that external data sourcing for you and help you. Well, actually, we'll do all of the data ingest for you, but the external sources come in on our side. The types of data you need internally can be anything, really, from customer information, like demographics on individual claimants. They go into the claims space, so actual details about the claims themselves, service providers, and all of their associated components. Like in the medical space, maybe prescription information, and in the automobile space, maybe it's something like associated automobiles. All of that information helps. And I would say that no matter what you have, we can help infill that information where and if there are gaps. And it doesn't take much. Again, call us up, call me up, shoot me an email specifically. I'm happy to chat through this stuff if you have specific questions about your individual data.
Great. Well, thank you so much. Just as a quick reminder, we were recording today's session. There will be an email coming out this week with a copy of it. If you have any questions, feel free to reply to that email or to either Scott or Graham, and we will be happy to assist you. Thanks again for coming to today's session, and we look forward to the next one. Have a great day.